Hello, Nonlinear. I hope you guys are doing well. This is section 10.5. We have two goals for today. One goal would be to be able to construct a box and whisker plot, and the other one is we want to decide if a data point is an outlier. We do have some terms. We have gone over these in a previous video, but let's go over them again just to be sure. Some things you guys need to know would be range and median. Which I do believe you guys know those things. Range would be the largest number, subtract the smallest number. In the median is the middle point when put in order from smallest to greatest. So one of the other definitions that you guys need to know is you guys need to know what the lower quartile is. The lower quartile is, so once you have found the median, right, you list all the numbers in numeric order, right? So all the numbers are in order here, and you have the median, let's say this is the median. What you would then do to find the lower quartile is you would take the median of the lower half of data. So if there is a median, like one number in the median, you forget about it, and then you would find the median of the lower half. And that would be quartile, meaning fourth. It's the lower fourth of the data. I'll do that in a second here. We're also going to have the upper quartile, and the upper quartile would be the median of the top half of the numbers, the larger set of numbers. So you just go from greatest to least of this data set, and that will tell you the upper quartile. Within the interquartile range is the range between the lower and the upper quartile. Essentially what you do is you take Q3, the upper quartile. This is Q3, and this is Q1, it's called. You take Q3 and subtract Q1, and that will tell you what the interquartile range is. Lastly, the definition, last definition would be an outlier. And an outlier is a value that is widely separated from the rest of the data. So essentially, you're going to have a bunch of numbers, and then there might be one number that is far greater or far less than the data set. So much so that it doesn't seem to fit with the data set. Perhaps it was a typing error, or there was a unique situation that led to this outlier being in the data set. An example of an outlier in a data set would be if I took all of our ages in nonlinear and included my age in there. There would be a whole bunch of the same age. Everybody's within, pretty close to each other, and then my age is far greater. I would be the outlier in that situation. So one of the tasks, like I said, that we're trying to do is we're trying to be able to identify if a data value is indeed an outlier, is indeed far enough separated where it would be considered by definition an outlier. So in order to construct a box and whisker plot, I put some directions here. You're going to need to find 5 important values. It's called the 5-number summary. Sometimes you need to know the minimum, the lower quartile, the median, the upper quartile, and the maximum. You're going to make a number line then, numbers on a number line, and you are going to create this thing called a box and whisker plot. The box goes from the lower quartile to the median to the upper quartile. So it's a rectangle with a line at the median. And then let's say this was the minimum value. These have whiskers that go to them. So this is the minimum value and the maximum value. And that's the shape of a box and whisker plot. Let's look at an example. I'm not going to use this one. I'm going to use this data set. We've used this data set in the past. These are ages of people at Applebee's during their half price appetizers. Okay, so we have all the ages. We need to know the median, and so we need to identify the middle number. They are already in numeric order, so I just need to start finding the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to cross off 9 on the lower half. Then 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 1, 2, 1, 2. 19 is the median age. So I know the median. I also do know the minimum is 6 and the maximum is 42. To find the lower quartile, I'm going to, because I just got one number as my median, I'm going to cross that off and I'm going to find the median of the lower half of the data. So I'm going to start here. I'm going to cross off 1, 2, 3, 4 numbers. 1, 2, 3, 4. Okay, I can tell that 16 then is the lower quartile. And I can do the same thing for the upper quartile. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 26 is the upper quartile. So now I need to put them on a number line. I'm going to start at 0 and count by 5. 0, 5, 10, 15, 20, 25, 30, and so on. So, like I said, the lower quartile, median, and upper quartile have like a rectangle around them here, 16, 19, and 26. They get a box around them. And then a dot out here at 42. This is the whisker part. The dot here at 6, and that's connected to the box. Yeah, another whisker, and there's my box and whisker plot. So we've accomplished the first task. We wanted to be able to construct a box and whisker plot. The second thing that I wanted to be able to do is identify if there happen to be any outliers in the data set. So are there any data values that are far enough removed from the norm that we consider them a mathematical outlier? In order to identify if something is an outlier, our first step is to calculate IQR. Remember, I defined IQR on the definitions page. IQR is Q3 subtract Q1. The upper quartile subtract the lower quartile. We're going to use this data set once again to find out if we have an outlier. Upper quartile is 26, and the lower quartile is 16. So the IQR would just be 10. Pretty convenient. So what you're going to do then, step 2 says to take the IQR, which we said was 10, and multiply it by 1.5 to get this number that I refer to as L, which I use that for like a limit. But you take 10 and multiply it by 1.5, you're going to get 15. So step 3 says use this number, L, which we said is 15, to see if any data points are larger than the upper quartile plus L, or smaller than the lower quartile minus L. If they are outliers. So let's revisit our box and whisker plot. Right here we have our lower quartile, and right here we have our upper quartile. This says upper quartile, by the way. It's kind of ugly. Just pretend. So what you're going to do to these values is you are going to add 15 units to the upper quartile, and you're going to subtract 15 units from the lower quartile. And you are going to then see if there are any numbers that are outside of 15 above and 15 below the upper quartile and lower quartile. If there are any outside of that, they're outliers. So our lower quartile is 16. We're going to subtract 16 to get 1. 16 minus 15 would be 1, yeah? And then for the upper quartile, we're going to add 15. Adding 15 to 26 would give us 41. So how we would use these values is anything between 1 and 41 is going to be acceptable. Okay? Anything between 1 and 41 would not be outliers. When we look at our data set, all of our numbers smaller than like the median are within this range, 1 through 41. But we do have some old person at 42 checking in who is far removed from the rest of the data set, right? They're actually just on the bubble of being an outlier, but they are larger than our interval 1 through 41. So then the person who's 42 is an outlier. So these are the steps for creating a box and whisker plot and also deciding if something is an outlier. You have a couple of questions that basically do the same thing for homework. Please let me know if you have any questions.